So right now, let's look at the overview of the TCP IP networking model. So when I say TCP IP networking model, the TCP IP model both defines and refines a large collections of protocols that allows computers to communicate. The TCP model also avoid repeating of works which is already done by someone or some other standardization bodies. So we can just avoid repeating of words. And also the TCP IP model creates a set of rules that allow us to take a computer out of the box, plug into the right cables and turn it on. So you can use a web browser to connect to your favorite website, or you can use the app or everything. That all simply works once you connect the model or once you connect the computer to that network. So well, then how does it work? It's because the operating system on the computer implemented the TCP/IP model. The network Ethernet card or the Wi-Fi adapter is also using the TCP/IP model. So that's mean the software and the hardware is implemented on the TCP/IP model. So what happens is, since everything on the network from the device to the network is following the TCP/IP model, so they can easily communicate with each other. To understand this networking model, each model breaks the functions into a small number of categories called as layers. As you can see here, we have got a couple of layers. Here you have a application layer, transport layer, network layer, data link layer, and physical layer. So technically in TCP/IP we had 4 layers. This is the 5-layer model, but in the past we had 4-layer model. This shows a 5-layer model for you to understand easily the different layers. Right. So the bottom layer here, the physical layer, focus on how to transmit bits over each individual links, which means when two computers are connected using a cable, we call that connection with the connection part, we call it as link. So the physical layer takes the responsibility of transmitting bits from one computer to the other computer. Why we call it bits instead of data? Remember, the data is what we have in the computer. But once the data has gone through all the encapsulation process, that will convert into bits, and the bits, which is the electric signals, will leave the computer and go through the medium and reach the other device. So whatever we have in this communication medium is what called electrical pulse, which is bits, right? In technically it's a digital communication, so we call it as a bit, zeros and ones, right? So the same way, the data layer focus on sending data over one type of physical link. For instance, network uses different data link protocols for LAN, and they use different data link layer protocol for wireless LAN. So we will go and learn these ones later on. Same way, the network layer focus on delivering the data over the entire path from the original sending computer to the destination. So network layer takes the data and reads the source IP address and the destination IP address information and goes back to a table called routing table, finds the best path to reach the destination, and then put that file or the data, which is bits, into the right path so that it can reach the destination. To do this one, the routers does something called routing. So routing is what? Taking a decision to find the best path to reach the destination, right? Same way on the top layers, top 2 layers, which is your transport and the application layer, they work or they focus more on the application that needs to send and receive data, which is like emails, web browsers. So all different types of applications will be taken care in this application layer, right? So this is how a TCP/IP model is working. So if you look at the TCP/IP model, it has 5 layers or it has 4 layers. So you can call it 4 layers, 5 layers, it's fine. So each layer has set of defined tasks, and each layer does those tasks so that the data can go from one end to the other end. So here it says everything here. The bottom layer focus on how to transmit bits over each individual link. Data link layer focus on sending data over one type of physical link, which is could be LAN or wireless LAN. Then the network layer focus on delivering data over the entire path from original source to the destination. The top two layers, which is application and transport layer, taking care of the application that need to send and receive data. So that's what the TCP/IP model do for us to help communication, right? So here we have the comparison. Remember I said like 5 layers and 4 layers. So technically TCP/IP was a 4-layer model: application layer, transport layer, internet and link layer, or physical link layer. For us to understand easily, we divided the physical link layer or the link layer into 2 different layers as called data link layer and physical layer. If you compare this with the OSI layer has 7 different layers. So they have physical layer, we call it as please do not throw sausage pizzas away. So on the here we have a physical layer, data link layer, right, network layer, transport layer. Then we have session layer, presentation layer, application layer. So 7 layers. So OSI has 7 layers, TCP/IP original has 4 layers, and the newly updated one has got 5 layers. So the whole reason of why we have these 5 layers is for the easy understanding, right? So hope you understand the functionalities of each layers and what they do. So based on this is what the network is communicating. So if you look at it here, TCP/IP layers and the protocols we have for each layers. So here we have layers application, transport, internet and link. So here application, transport, internet and link layer. And what type of protocols are there? Protocols means set of rules are there in each of these layers. So in the application layer, we have HTTP, HTTPS. We don't use anymore HTTP. Now it's all HTTPS. Same way, POP3. POP3 is quite outdated. So now we are using IMAP, and Microsoft using different protocol called Microsoft ActiveSync. So there are different protocols for email communication. So HTTP and HTTPS is for the web browsing. POP and IMAP is for the email communication. SMTP, Simple Mail Transfer Protocol, is to send the emails, whereas POP and IMAP is to receive the email. So these are some examples of the application layer protocol. Similarly, we have in the transport layer, there's only 2 protocols we have, TCP and UCP, Transmission Control Protocol, User Datagram Protocol. We will go and learn the difference between TCP and UDP later on. So TCP is considered as a reliable transmission protocol. UDP is called unreliable transmission protocol. So we'll come back and see what is the difference between reliable and unreliable. So in the internet layer, again, we have got 2 different protocols, IP and ICMP. ICMP is called Internet Control Management Protocol. So ICMP is used to send and receive a ping packet, right? So especially it's to send and receive messages, so that what happens when you send the messages, we can say whether the end device is available or not, right? So we can use ICMP. So IP is the most common protocol that we use in the network. It's internet protocol. That means it has a numbering system to identify the devices uniquely in the network. We will go and study different types of IP protocols, IP version 4, IP version 6. Right now, industry is moving towards IPv6, or almost IPv6 is implemented. We'll go and learn about those ones in the upcoming chapters. Then in data link layer and physical layer, we have different standard. Ethernet 802.11, which is your wireless standard. So 802.11a, b, g, n, different types of standards are available. So these are Ethernet. Same way on the WAN side, that's the LAN side is what Ethernet and Wi-Fi. On the WAN side, we have frame layer, HDLC, different types of protocols available. So we will learn these types of protocols and what they do when we go through those kind of protocols, right, at times. Right, so that's all about the layers and what they do in each layers and what protocols are available in each layers. So the next topic, we are going to look at the TCP IP application layer protocol. The common protocol in the application layer is HTTP or HTTPS. So we're going to talk about the difference between HTTP, HTTPS, and how they work.